Hello, my name is Colby Johnson. This is going to be my BIO.103 final project. Today I hope to teach you a thing or two about protacts. Now you're probably asking yourself, what is a protact? Protact stands for Proteolysis Targeting Chimera, which is a chimera molecule that is composed of two separate molecules that can bind together and also bind to certain disease-causing proteins and target them for destruction by the body's own natural disposal system. Protacts target and remove proteins using the proteasome. The proteasome is a natural regulatory system within the body that removes damaged or unneeded proteins via proteolysis. Proteolysis is a chemical reaction that breaks down peptide bonds within the proteins. The way that the protacts remove these proteins is by using the special chimera molecule to bind to one end of the E3 ubiquitin ligase, which is a protein within the body that promotes protein degradation, and the other end targets the specific disease-causing protein. Once the chimera molecule has been bound to these two proteins, the disease-causing protein is then marked for deletion and will be removed by the proteasome. As you can see here, this is a model of how the protact works. Here's the E3 ubiquitin ligase. Here's the protact. One end of the chimera molecule binds to the E3 ubiquitin ligase, and the other end binds to the target protein. Once the molecule has been bound to these, the proteasome can then remove it, as you can see here. Next, I'm going to talk about some of the uses of protacts. Here we can see influenza, and here is a up-close picture of certain disease-causing proteins, which can lead to a variety of neurological conditions. I included these images because the protact can be used to treat cancers, neurological conditions, and diseases that are more resistant to other forms of treatment. Some diseases, such as cancer or Alzheimer's, are more resistant to drugs due to the disease-causing proteins being too small to be targeted by the drugs. Even drugs that were specifically created to target these smaller molecules or proteins, such as small molecule inhibitors or antibodies. But protacts don't have these same limitations because they bind directly to the proteins. Another use for them that researchers have been developing is using them in vaccines, such as an influenza vaccine. They can use protacts in vaccines by targeting the specific proteins that lead to the virus replicating within the body, but leaving the proteins that your body needs to teach your immune system how to fight off these viruses. Meaning with protacts, we can create vaccines that are still as effective as the ones we have, but there's no risk of the virus replicating once it's in your system. The development of protacts. Protacts were developed building off of existing small molecule and antibody treatments. The precursor to protacts were small interfering NRA, also known as siNRA, which is a segment of NRA that interferes with the synthesis of certain disease-causing proteins. The other precursor to protacts was synthetic chemical molecules. These are conventionally small chemical molecules which were designed to be bound to proteins. However, each of these treatments has their own issues. For example, the siNRA was too inaccurate in its delivery system, which could lead to unexpected consequences when it was injected into the body. And when the synthetic chemical molecules bound to a certain protein, the proteins quickly grew a resistance to them. To overcome these limitations, researchers looked into protein-to-protein interactions. This eventually led them to induce protein degradation in the form of proteolysis targeting chimeras, or protacts. And here's my works cited page. Thank you for listening. I hope I was able to teach you a thing or two about protacts.